In this video, we'll be solving some more right triangles. To solve a triangle means to find all measures of sides and angles. The example that we'll be doing is to solve right triangle ABC if side A measures 44.25 centimeters and side B measures 55.87 centimeters. Now the first thing I would do before I draw a sketch is to notice that these side measures are both 4 significant digits. So when I give my angle measures, I need them also to be 4 significant digits, which means I need either to the nearest minute or the nearest hundredth of a degree. And let's draw our sketch. Whenever we label our right triangle, we need to make sure that we put point C as the vertex of our right angle. But then A and B, it doesn't matter. We can put A at the top and B at the bottom, or vice versa. Now we know that side A is 44.25. Side A is the side opposite angle A. So we would write A is 44.25 down here. And then B is 55.87. That side is opposite angle B. So B is equal to 55.87. And then C is opposite my right angle. Now I can find side C immediately with the Pythagorean theorem. I know that the square of the legs added together is equal to the square of the hypotenuse. So let me write that. 44.25 squared added to 55.87 squared will equal C squared. Now since I'm not dealing with any trig, I don't need to worry about the degree or anything. I just need to do this math. So 44.25 squared plus 55.87 squared, and that equals 5079.5. And I don't need to worry about significant digits here because I'm going to keep my number in the calculator. Don't clear it out. I just wrote this down to give me a middle point to check, just in case I have an error. I do need a square root both sides to get C. Square root of my answer is, now I need 4 significant digits on my side, so 71.27. Now I can store that. I'll put it in A in case I need it. Alright, now I need to find angle A and angle B. Let's just find angle B. we can, using the two sides that I already know, side B is opposite angle B, and side A is adjacent to angle B. So the trig function that uses opposite and adjacent is tangent. So I can say that the tangent of angle B is equal to the opposite side divided by the adjacent side. Now whenever I'm looking for the angle, I don't know the angle, so I need to use my inverse trig function. So I'm going to inverse tangent on both sides. And when I inverse tangent, I get just B. And then on my calculator, now this time I am dealing with trig, so I need to make sure I'm in degree mode. I want second tangent, 55.87 divided by 44.25. Close my argument and hit equal. So my angle then is, and I need 4 significant digits, which means I need to the nearest hundredth of a degree right here. So 51.62. Right. Now, angle A and angle B are the acute angles of a right triangle, so we know they're complementary, which means to get angle A, all I need to do is subtract angle B from 90. So 90 minus 51.62. This is decimal degrees, so I don't need to worry about borrowing a degree. I'm just going to borrow as we normally would in base 10. So this becomes an 8 and 10 there. And then this is 9 and 10 there. And this is 9 and 10 there. So we have 8, 3, 8, and 3. So looks like angle A is equal to 38.38 degrees.